good place to start. Is this the one you just went with? The practice test? Yeah. Yes. Perfect. Yeah, make sure you grab a practice test. And Ann, thank you. Okay. Recording, not on mute. Check, check. Good. Okay. So, written assignment 1, due right now. Make sure you hand that in. Okay. So, written assignment 1. Due now. Thank you. Okay. Still got till next day for written assignment 2. Okay. What you'll want to do is, because you won't get your actual marks back, right? Feedback for written assignment 2, before you hand it in next day, you'll want to take pictures of it, right? Because I'll post the solutions so that you can check your work against the solutions. Okay. So that's just so that you can check your work without having to get your marks back, right? Because the test number 2, is on Monday. Next Monday, obviously. We're gonna get it out of the way before the long weekend. Sounds good. Okay. So we'll do the review next day. Review on Wednesday. All right. So same as last time, right? Complete the practice test, right? Even if it's wrong, I don't care. As long as you've tried all those questions and show me all that work, right? You'll get 1 completion mark. Okay. So complete the practice test before class on Wednesday. What? That's so much work. I know, but think how prepared you'll be for the test. For 1 completion mark. I'm going to count these completion marks as an assignment. Okay, so easy assignment marks coming your way. Okay. Remember, just try it, even if it's wrong, go through it, and then we'll go through it together, right? And then that'll sort out any kinks, right? So it doesn't have to be right at all. Because I think that's what bothered a lot of people. How am I supposed to do this if I don't know if it's right or not? Just try it. We'll go through it. We got it. Okay. All right. So, oof, feels so long ago. What were we doing? Compound interest. So let's do a little bit of review, right? We're going to finish up chapter 5. I promised I'd show you how to use the time value money functions on your calculator today. So that'll be pretty fun, right? You'll be able to finish assignment 2, right? Because there's some calculator questions on there, but once we know how to use it, we'll be good to go. Okay. So any questions before we start? What, there's a test? Yeah, there's a test. I know. So review. Thanks. We looked at, well, we're still looking at compound interest. Right, we use the future value as the present value times 1 plus I to the power of n. And we solved for all of these things, right? We've solved for the present value, we solved for I, we even solved for n, even though it's a little bit tricky. right? But all these things are on your formula sheet. Of course, you will have, just like test 1, a clean formula sheet, right? You have to use the one I give you, obviously. Can't use your own. Then you can just make notes and cheat. That doesn't work. Right? Oh, okay, well, in that case. I actually like to write on my own. Like, even if I had to use like the props formula sheet, I would always write on mine. And then I'd try to remember what my formula sheet looked like. I tried to overlay it on top of the other one. It's like, oh, just remember, okay, I had that there. Reproduce it in my mind. Anyways. Pardon? Yeah. So we solve for the present value, we solve for I, and we solve for n. Right. But all of those are on your formula sheet. Okay. Where I, remember, is the periodic interest rate. Periodic interest rate. Right, and I is R over F. Okay. F is the compounding frequency. And when we started chapter 5, right, we went through some of these common compounding frequencies, right? Monthly, we use F equals 12. Bi-weekly, we use F equals 26, right? Weekly, we use F is 52, right? Those things. So you have to remember those. And N, right, is the number of compoundings. So instead of time on our arrow for compound interest, right, you're going to use N, where N on your formula sheet is time times the frequency. Time is always in years, right? T is always in years. T is time in years. Right, so whatever you have to do to convert T to years, you got to do it. Okay. We looked at examples where we solved for the rate, right, the nominal rate and time, but in order to solve for the rate, we first had to solve for the periodic interest rate in order to solve for the nominal rate. Okay. Solving for R and T, right? Solve for R has 2 steps, right? Find I, and then use I equals R over F to solve for R, right? And then we looked at solving for T. Step 1, we have to find N. Step 2, we have to use N is time times the frequency to solve for T. So it was kind of this gateway situation. Right. Just the same as in the question, right? You'll be given R and T. You have to convert those to I and N, right? If you're solving for R and T, you have to convert I and N to R and T. Right? Solving for T, right? We have to find N. One thing that we said, if we find N and it's 10.3 whatever, right? We always have to round up, right, to the nearest whole number. Okay. So I'll put a little asterisk here. When solving for N, we always round up to the nearest whole value. The idea being if we round it down, if the number of compoundings that we need is 10.3, if we only went to 10, we wouldn't have quite as much as we were hoping to, right? And so we go to 11 compoundings, we'll have a little bit more than we were hoping for, right? But I think we can all agree that's a better situation than not having enough, right? We also looked at the doubling time, right, just briefly. So we can find the doubling time just quickly using the rule of 72. We take 72 divided by the rate as a percentage. Gives you an approximation for how long it's going to take something to double, right? And that's a good way to check stuff at the bank. So if they tell you a rate, oh, we can offer you this rate, right? Then you can do 72 divided by that rate, and that'll give you an idea of how long it's going to take something to double. It doesn't matter how much. So from $1 to $2, how long is that going to take? Right? If it's just accruing interest, $1,000 to $2,000, $1 million to $2 million, doesn't matter, right? So just how long is something going to take to double? And that's going to give you an idea of if that's a good rate or a bad rate, right? And so we said we can find the doubling time in years. Oops. This says time, yikes. By using the rule of 72. Thank you. Use R as a percentage. Right, so we said that the doubling time is roughly equal to 72 divided by R as a percentage. Right. So if I tell you, oh, I can offer you a rate of 3%, then how long is it going to take my money to double? 72 divided by 3, it's going to take 24 years. Am I okay with that, or probably won't have a choice? But yeah, just to get a quick approximation of how long it would take to double, approximately, right? 24 years for 3%. Okay. Right. Is that worth it? Depends on the scenario. Right. Long term, short term. Okay. So, any questions about that before we start our new stuff? That was all review? I know. Sounded vaguely familiar, I hope. Okay. So, let's just do an example just to warm up before I show you the calculator. So we'll start with a little example. Where did I have those? Here. Oops. Let's do example 187. Oops. So as we do more and more of these, right, and that's why I'm bombarding you with assignments and practice tests so that you see all these, and then what you'll start to notice is that there's really only a few different types of questions that I could ask you, right? Figure out some unknown payment amount, or figure out an equivalent value, right? How much is this payment plan worth at a certain point in time, right? That kind of thing. So for this example, I've decided to make annual contributions to a fund in order to have $10,000 in 3 years so that I can purchase a car. Hey, sounds good. Each contribution will be of equal value, and the fund into which I am contributing earns a rate of return of 4.4% compounded quarterly. 4.4% compounded quarterly, it's too good to be true. How much must I contribute each year? So what are these unknown payment amounts, right, that we have to figure out? So we're going to start with a timeline, right? I'm going to highlight that this is compound interest, right, here. Because on the test, on test 2, right, it's going to be simple interest or compound interest. Right, so we want to get in the habit of being, because the formulas are different, right? If you look at your formula sheet, we know we have to use different formulas. So the first thing you're going to do is say, okay, is this a compound interest problem or a simple interest problem? Right? We're in compound interest, so it's going to be compound interest for now, right? But on the test, it can be either or, right? So you want to keep track of that. And maybe as you're going through the practice test, right, make sure that you remind yourself if you're dealing with simple interest or compound interest. Okay? So we've got compound interest. Compound interest problem. That's just a quick little note to me so that I remember. Okay. So I'll start with my timeline, right? I have to figure out what dates I'm talking about, right? So I'm going to make annual contributions, and each contribution will be of equal value, and for 3 years I'm making contributions. Okay. So I'm going to start today and go for 3 years. Oops. One, 2, 3. 1 year, 2 years, 3 years. This one, it's not really clear if we're going to make a payment today or if it's going to be a year from now, right? On the test, it'll be clear when you're making payments and when you're not, right? But I'm going to tell you that we're going to make a payment today, right? So I'm going to make a payment today. I'm going to make a payment in 1 year, a payment in 2 years, and a payment in 3 years, right? I'm just using X because I don't know the amount. The whole point of this question is to figure out what X is going to be, right? Okay. And they're all X because they're all of equal value, right? So we know that. On your assignment, right, we've had the third payment is 3 times the second payment, right? So then you would have something like 3X like we looked at last day. Okay. So the total at 3 years has to be 10,000, right? Because that's the whole goal. I'm trying to save up $10,000. How much do I need to put away each year to make that happen? Okay. So what I'm saying then is that, okay, if I know the total at 3 years, even though I don't tell you what to use as the focal date, right? If I know that at this point here, at 3 years, I need the total to be 10,000, right? It just kind of makes sense to pull all these payments to 10,000, right? So basically, for 3 years. Yeah. So then here, right? I'll just make a note here that this is what I'm using as my focal date. And on your assignment, I say, it doesn't matter which one you use as your focal date. For simple interest, it matters, but for compound interest, it doesn't matter what you use as your focal date. It can move around, doesn't matter. Okay? as long as you pick one and stick with it, right? You're not going to do this wrong. Okay? So I'm going to use 3 years as the focal date. You could use something else. Okay? But I think 3 years is the easiest. Okay? So this little guy gets pulled forward. It's going to become some future value 1. Right? This little guy is going to become some future value 2, and this little guy is some future value 3. Right? Because even though these x's are all the same amount, right? This x is going to be contributing way more in the end than this one, and this one's going to be contributing more than this one, and this one more than this one, right? Because here we've invested it, and it's been earning 4.4% compounded quarterly for 3 years. Right? Here, this one's been sitting there for 2 years, right? And so those future values are all going to be different, right? But the x's are going to be the same. So then I'm saying that the total here has to be 10,000, right? That's my savings goal, right? Okay. Next thing I'm going to do is I'm going to put my ends on these arrows, right? For simple interest, we put time on the arrows. For compound interest, we put our n on these arrows. So n is time times the frequency. The time in years between 2 years and 3 years is just 1, right? And I'll just jot down here that we have an f equal to 4, right? We're compounding quarterly 4 times per year, so f must be 4. Right. While I'm at it up here, I'll just jot down that r is 0.044. Right. Just stealing the 4.4% compounded quarterly, just jotting it down somewhere so that I have it. So now going back to this n is time, which is 1, times the frequency, which is 4. So I've got 4 compoundings in there on that line. For future value 2, right, the length between 1 year and 3 years, 2 years. So n is time times the frequency, which is 2 times 4, which is 8 compoundings. For future value 3, that one's been in there the longest. N is time times the frequency, which is 3 years times 4, so 12 compoundings. Our timeline is not complete without calculating our periodic interest rate, right? So we can just do that somewhere down here because it's going to be the same for all these arrows, right? So it doesn't matter. I is R over F. R is 0.044 divided by F, which is 4. I'm thinking 0.011. So here's our complete timeline, right? Nice. Nothing extra here. I'll just show that here. Complete timeline. And for these assignments, right, I'm going to mark your timelines and your work really hard, right? Because these ones you'll have back next day, right? And then you'll know what to expect for the test, right? Because your timelines have to be really good. So why do I care about the timelines? Well, this is just a map of what we're about to do, right? The calculations aren't that hard. We've got 3 future values that we have to calculate. We have to set them equal to 10,000, and then we have to solve for x, and then we're done, right? This is the hard part. Okay. So we can solve for future value 1. Future value 1 on our formula sheet is the present value times 1 plus I to the power of n. Remember, the present value is always the one on the left-hand side of your arrow, and on the right-hand side, you always have your future value, right? So no matter which direction the arrow is going, right? On the left, you've got your present value. On the right, you've got your future value. So here, your present value is going to be x for all of these, right? So the present value is x times 1 plus 0.011 to the power of n for this one is 4. Really, the only thing that's going to change for all these calculations is the n. I is the same for all of them. The present value is x for all of these. So now we've got 1 plus 0.011 to the power of 4. I'm going to write the decimal first and then times x. 1.04473139 x. Right, that's your future value 1. I'll store this in 1 because I know I'll need it later. All right, so store this in 1. And I'll make a little note to myself. And we went through how to store stuff in your calculator. You just hit store and then put it in whatever slot you want to put it in, right? You can use any of the values, any of the numbers. Okay. I don't think you can use any of the functions like plus or equals. You can use 0, just, I haven't even tried to use the division sign or something like that. We've got 10 slots to fill, so we don't need to. Okay. But I am curious if it works. I don't think so. So then moving on to future value 2 then, right? N for future value 2 is 8. So we've got the present value times 1 plus I to the n. Present value is x again times 1 plus 0.011 to the power of 8. 1.011 to the power of 8. I get 1.09146,357 times x. I'll store this in 2. Future value 3 is the present value times 1 plus I to the n. Present value is still x times 1 plus 0.011 to the power of 12. 1.011 to the power of 12. I get 1.140286196 x. I'll store this in 3. Okay. So now we know that 10,000 has to equal, and don't forget about that x at 3 years, right? X plus future value 1 plus future value 2 plus future value 3. Right? So x plus future value 1 plus future value 2 plus future value 3. Okay. All right. That's x plus future value 1, which was, I'll just recall 1. 1.044731339x plus future value 2, recall 2, 1.09146357x plus future value 3, which was 1.140286196x. This is why we stored all these, right? Because now we can collect like terms. We've got 1x plus 1.04x plus 1.09x plus 1.14x, right? But you want to keep all your decimal places because when we're dealing with money, we don't want to be rounding, right? We want to keep all our decimal places because it can make a big difference. Okay. So we've got 1 plus recall 1 plus recall 2 plus recall 3, right? But don't forget that 1x. So I get 4.27648110.5x. Make sure you get the same thing. And this whole time, this has always been equal to 10,000. So to solve for x, right, I can divide both sides by 4.276. So x must be 10,000 divided by 4.27648110.5. 10,000 divided by that guy. I get 2,338 and 37 pennies. Right. So each payment here must be $2,338 and whatever pennies, I can't remember, 37. At each of these points. And those are all equal. Okay. And that takes into account that you're going to invest this 2,338.37 for 3 years. That amount's going in for 2 years. This amount's going in for 1 year, right? And that one isn't going to gain any interest at all. Cool. Any questions about that one? So if you've been looking at the assignment, you should feel kind of familiar. That's right. You use T. Yeah. Cool. Any other questions? No? All right. So you want to know how to use the calculator, huh? Okay. So 5.5, section 5.5 in your textbook goes through and shows you how to use your calculator, but we'll just go through it today. So using your calculator for compound interest problems. We'll call this the TVM, time value money functions of calculator. So, unfortunately, it doesn't do simple interest, but that's okay. We've got simple interest under control, right? But it does know how to deal with compound interest and beyond. Okay? And so these white buttons is what you paid your big monies for. Okay? Should look kind of familiar, right? You've got N you've got your interest per year, you've got your present value, you've got a payment amount that we haven't touched yet, okay? But you've got a future value. And then if you look above the interest per year, you've got P per year. That's going to be your payments per year. Okay? So there's going to be all these buttons that we need to fill with information. And then just like we did with the days between dates, we can go back and ask it to compute one of the ones that we've left empty. Right? So we're going to go through, we're going to fill all these little pockets with information, leaving the one that we want to solve for, and then we go back and we tell it, okay, now you know everything, compute this, give it to me. Okay. So your calculator needs the following information. Just going through the list of the white buttons, right? We've got a capital N, I per Y, present value, PMT, future value, and then we're going to find the P per year and the C per year. So the last two we're gonna access by going the second interest per year. Okay. So if you just hit second interest per year, it'll have payments per year, and then you can scroll down C per year, the compoundings per year. Okay. So that's where we're gonna put our compounding frequency. Okay. First, I'm gonna go through and I'm gonna tell you what each of these things are, right? And then what we fill in if we don't know what something is or whatever. So N is the number of compoundings. Right? Interest per year is the nominal interest rates. So the interest rate that's actually in your question, right? Not the periodic interest rate, okay? And as a percentage. Right, so in the previous example, you had 4.4%, right? So you would just put 4.4. Okay. So it's the nominal interest rate as a percentage. PV is just your present value. PMT is your payment amount. Okay. For now, right, we don't have any payment amounts. Okay. So we're gonna use 0 for now. So we'll just be entering 0 for the payment amounts. Until I think chapter 6, I want to say. Yeah. Until annuities, then we'll have payment amounts. Okay. FV is your future value. P per year is the payments per year. And what we're going to do is we're going to use same as compoundings per year for now. In fact, when we change the compoundings per year, it'll automatically change the payments per year. Okay. Where the compoundings per year is C per Y. compoundings per year, which is just your F, right? So for some of these questions, right, on the assignment, I make you do both, right? Answer this with your calculator and then check your answer with the calculator, right? On the test, unless I say do this by hand, you're definitely allowed to use your calculator, right? But as far as showing your work goes, you have to give me this entire list and tell me what you're putting in for each of those slots, right? And that's going to be how you show your work. So using your calculator is not cheating, right? It gets you to the answer, so I don't really care, right? But there will be, especially on the final, there will be some questions where it says you have to do it by hand, right? So you have to know both ways, and that's what I'm doing on assignment 2, is I'm getting you used to doing it both ways, right? And then that way you'll know which way you prefer too. Maybe you prefer to do it by hand. Doubt it. Okay. So I prefer to do it by hand, but here, I'll make a note here. These are you're gonna get to by using the second and then interest per year button. And scroll down to get the compoundings per year. Okay. So those are in a second menu option. Okay. So if you're in the second menu, right, we've done things in the second menu, right? The days between dates, we had to hit enter to store them, right? So same here, when we're entering the compoundings per year, we have to hit enter to store them, right? So I'll just, must hit enter to store values. For payments per year and compoundings per year. Okay. That's just how the second menu works. In general, though, for N and interest per year, present value, payment amounts, future value, you're just gonna put the amount that you want to put in, right, on your screen. So you're gonna have, let's say N is 15, right? You're gonna say 15, hit N. It'll say N equals 15. Great, moving on. The interest rate, let's say, was 4.4. So 4.4 interest per year. It's saying, fine, interest per year, 4.4, right? So how you're gonna fill these slots is you're just gonna put it on your screen, hit the button you wanna store it in, and then move on, right? It'll remember stuff from previous questions, right? So if you're reusing the same interest per year, maybe the same present value or something like that, you don't have to keep re-entering those. They'll just be there from the previous question, right? So okay. To fill slots on our calculator, enter the value that you want, and then hit the slot you want to fill it into, if that makes sense. Okay. To fill slots on our calculator, enter the value you want, then hit the button you want to fill it into. The one you want to solve for, initially you're going to enter 0, right? And then you're going to go back and hit compute this value, right? So the value we want to solve for will initially be filled with 0. Then we go back and use the compute button, right, to compute the value. Then once all values are filled, we go back and use the CPT, right, the compute button, to compute the missing value. One note is that the future value and the present value have to have opposite signs, meaning one has to be positive and one has to be negative. For now, it doesn't matter which one's which, right? If you enter a positive present value, the answer it gives you will be negative, right? The idea being that how the money is flowing from you, right? So if I deposit money to the bank, right, it's leaving my hands, so then I'm negative that amount, right? And if I take it out, right, then I get that money, so then it's positive, right? So that's the convention that we'll use later on. For now, they just have to have opposite signs, right? But it might be good to get in the habit of thinking about, okay, well, they have to have opposite signs. Which one would be positive? Which one would be negative? Again, it doesn't matter for this section, right? But later on it will, right? And so let's write that down. So note, the values we enter for present value and future value must have opposite signs. Right. So one is positive, one is negative. For now, it doesn't matter which one's which. For now, it doesn't matter which one is which. Okay. But later, we will use the convention that if money is leaving our hands, money leaving our hands is going to be negative. Right, so I deposit it to the bank, I pay back a loan, right? Deposit to the bank, pay back a loan. Whereas if we, money, I guess, coming into our hands, we're going to make it positive, right? So it's good to get in the habit of this right away. But like I said, it's not going to make or break you for this section. So money coming into our hands, right? Even if I apply for a loan, right, I get that amount, that loan amount, and then I have to pay it back, right? But that amount is going to be positive to me, right? Or someone pays me back, that amount is positive to me, right? So if I get a loan, someone pays me money. Right. Some examples. Okay. So it's from the point of view of me, myself, and I. Right? Am I getting rid of money, even if it's going into my bank account to accrue interest, right? It's leaving my hands, going into the bank, right? So then it's negative. If I'm getting some monies, right, whether it be borrowed or rightfully mine, right, it's going to be positive. Okay. So I think we're better off doing this with an example, right? So we'll try out our calculator functions with example 189. Whoa. So example 189, determine the number of compounding periods, right? So we want to find n that it takes for an investment of $10,000 to reach $12,000 if money earns a rate of interest of 5% per year, compounded monthly, right? We're pretty good at solving these by hand now, right? All your practice, I know. Right? So now we're going to look at how do we solve this using our calculator. I'm going to map it out with a quick timeline, right? For something simple like this, you don't need a timeline, but I like to draw timelines. And you will too, eventually. So let's say today to some unknown time, right, we need $10,000 to grow to $12,000. We're trying to solve for n. All right. This question's kind of nice because I'm just asking for the number of compounding periods, right? Usually I would say, how long does this take? Right. Then you'd have to solve for n, which you can do using your calculator, and then solve for t. Right? And we've got r is 0.05, and the frequency, the compounding frequency is monthly, so we've got 12. Right? So if those compounding frequencies aren't coming to you right away, right, you might want to have a look at page, very beginning of chapter 5 here. Page number 121. And goes through a list of the most common compounding frequencies. So it's the very first page of chapter 5. Okay. So then I need to find I. I is the rate over the frequency, which is 0.05 over 12. 0.05 divided by 12, 0.004166 repeating. Let you in on a secret though, if we're using our calculator, we don't actually need to use I, right? But if you're using your calculator on the test, that's fine, but you still have to show me that you know that you have to calculate I if you were to do it by hand, right? So your complete timeline still has I on it, but you don't necessarily have to use it if you're using your calculator. Okay. I'll just make a note of that here. include I for a complete timeline, even if using your calculator to solve. Right. Okay. So we want to solve for n, right? So on our calculator, here's how I would show my work, and you would too if you're using your calculator. You're going to go through and list all the functions, the white functions, and then the payments per year and the compoundings per year, right? So we've got n, interest per year, present value, payment, future value, payments per year, and compoundings per year. Okay. Just like we did with the days between dates, right? I'm going to put a star by the one that I'm going to go back and compute. Right. Computing again. Right. The interest per year is going to be this 5%, right? So the tricky part is for all our calculations, right? I've been converted to a decimal, and now for the calculator, they just want 5. Right? The nominal interest rate as the percentage. Okay. Our present value is the $10,000, right? We can also jot in our future value, our $12,000, right? So 10,000 grows to 12,000. If you tried to use both of these as positive, right, it's going to complain, has to have one of them negative. So let's try to think in terms of, okay, money leaving my hands. And so it takes an investment of 10,000. So let's assume that I'm investing this 10,000, right? It's leaving my hands. And then at the end, I get 12,000. Right? So as long as one of them is negative and one's positive, you're fine. Right? I'll just make a quick note here. I'm investing, 10,000. Right. Making it negative. The payment, like I said, we just use 0. Right? We don't have a regular payment amount. That's not going to come up until annuities. Use 0 until annuities. Future value we've already got. Our payments per year, we said, well, we don't have any payments, and so the payments per year has to be the same as the compoundings per year. We said we have 12 compoundings per year, right? From F is 12, just making a note. Oh, I'll make it in my note blue, right? From F is 12. And so we're going to use the payments per year is 12, but that's just because it has to be the same as compoundings per year until annuities. I'll add that. Until annuities. Isn't that such a relief when you look at the back page of your formula sheet to know that you'll be able to do all these on your calculator instead? Phew. Right? Yeah. So here, right, we've got our work if we're using our calculator. Okay. All right, so now we're going to plug in these values in our calculator. Remember to use 0 for n, and then we're going to come back and compute it. All right, so it's temporarily filled with 0. Then we can fill in all our values. Then we can go back and calculate it. Okay. So nothing to it but to do it. So you're going to do 5 interest per year, right? And then it should just say interest per year equals 5. Then it's ready to move on. 10,000 negative as your present value. 0 as your payment amount. 12,000 positive as your future value. So far, so good. Right. Now, if you go into your second payments per year, right, which is the interest per year button, look at the yellows, right, then you can scroll down. You can ignore the payments per year, because once you scroll down and do your compoundings per year, C per Y, right, hit 12, and it's not until you hit enter that it's going to keep it. Right? Enter. Right?
Sorry, I'm a little lost.
It's okay. Where are you? Oh yeah, so from the payments per year, right, you can scroll using your scroll buttons, right, up and down buttons. So you get in at payments per year, second interest per year gets you to payments per year. Right. You can scroll past that because that's just going to be the same as the compoundings per year. Go to the compoundings per year, put in 12, enter.
I got a question.
Yeah.
How do you make them stay in PB? I can't get PB to stay.
Like, did we get
Like I tried to my first.
No, you put the second and the first. The number in and you put enter.
Oh,
Or yeah, for the payments per year, is that what you mean? To get to the payments per year? Yeah. So then, thank you. So then, yes, so second payments per year, because you've already stored the interest per year, right? So then second payments per, or interest per year gets you to payments per year. Right? Yeah.
oh, I see.
And then from there, you can scroll down to compoundings per year.
Would you be writing the box
Yeah. Yeah. How about, I'll try to do a video instead. Where are we here? Oh. Same problem as before. Need a little boost. Whoa. Oh, and I think we had to turn the lights on last time. So I'll start from the beginning, of course. You can follow along. I know it's going to be a little sluggish, but oh. Like, where did my notes go? They're on my iPad. Can't see them. Okay? But we have, so we're trying to solve for n, right? So in the n slot, you're gonna put a 0. So you're gonna go 0 and then hit the n. Right? And then it'll say n equals 0. Right? That's good. You don't have to do anything else. So then we have to enter 5 for the interest per year, right? So then we're gonna go 5 interest per year. And now it's saying, okay, interest per year is 5. Great, moving on. Okay. Then we said our present value is gonna be 10,000, but negative. The negative? Hit the plus minus button down here. And store that in your present value, right? So your present value button. And now it should say present value is negative 10,000. Okay. Moving on. We don't have a payment amount, so we're going to go 0 for the payment. And now we don't have to worry about the payment. It's always going to be 0 unless we change it. It'll be 0 forever now, right? Or until we change it, I should say. Okay. Then we've got our future value. So now we're going to have 12,000 as our future value, right? So it should say future value is 12,000. Okay. Now the last two we want to fill in, right, is the payments per year and the compoundings per year. To get to those two, right, you're going to use the payments per year is the second function of the interest per year, right? So you're going to hit second interest per year. Oh. Try not to. Okay. And you should get to the payments per year menu. Doesn't matter how you do it. I'm going to go in and I'm going to change, right? I'm going to scroll down, trying to not cover all the buttons. I'm going to scroll down to the compoundings per year has to be 12, right? Because that's the one I know. And then just as a fact for now, right, until we get into annuities, we don't have any regular payments. And so we have to scroll up, right? So we're going to hit 12 here. And just like the days between dates, right, it's not stored until it has the C per Y equals, right? So if you're in the second menu, you always have to hit enter to store something. Okay?
You have to press twice.
So then enter. Just enter.
How do you get getting one? You go twice up?
Are you in the compoundings per year? So then enter 12, like push 1, 2 on your calculator. Okay. And then hit enter. And then you can scroll back up, right? Making sure that you've got this equal sign here. Otherwise it won't remember it. Right? Yeah. Pardon? Okay. So now we've got our compoundings per year is stored as 12. Now we can scroll back up to the payments per year. All we know is that it has to be the same as the compoundings per year. So you can hit 12 again, enter. And then to get out of here, right, you're going to go second, quit. Second, quit. Okay. Now you should be at 0. Okay. That's good. That's good. After a few, it'll make a lot more sense, especially when you do assignment 2, right? Where you're first answering, you know what the answer should be, right? Because you did it by hand. And we're feeling pretty comfortable doing it by hand now, right? So then when you check it with your calculator, right, you should get the same answer. Right? So now we want to compute n, right? So we want to hit compute, right? So CPT n. So now it's telling us that we need an n of 43.848271123, right? So that's what we would get if we solve for n by hand. Right? Nice. Okay, let me get out of here. Maybe I'll keep this set up for a little bit. Wreck my wrist. So n is 43.848271123. Maybe I'll throw a little box around it just to show that this is the one I've calculated. Right, so it wasn't in there to begin with. What do we do with our n? We can't have 0.84 of a compounding, right? We have two options. We can go to 43 and not have quite 12,000, or what we should be doing is going to 44 compoundings and having a little over 12,000. So we would need n equal to 44. Like we said at the beginning of class, always round up to the nearest whole value. And then from here, if I ask you how long is it going to take, right? How long is 44 compoundings? We could solve for that, right? I'll just add to the question, how long will it take? Well, n is time times the frequency. N we decided was 44. Time is what we want to find, and we said that the frequency was 12. So time must be 44 divided by 12. Time must be 3.67 years. Cool. I'll try to make a note here. See video around, what do we think? The hour mark? Around 1 hour? Probably make you watch some extra, but ish. But just as a little, right? Okay, cool. I gotta bring this down. It's really hard to write on an angle. My writing isn't that good to start with. So that's gonna take some practice, right? But we got it in us, right? How about we do another example? Where did I steal this one from, I wonder? I don't know where I stole that one from. We'll talk changing interest rates instead. Try to steal another example. I don't think I have one. No, it's because we're gonna use the calculator for all of them later. I mean, technically, you could go back and redo all the compound interest questions on your calculator. Nah. How about if we did something like example 188. I don't have a picture of it, so I'll just write it down. It's quick. So $500 is invested at 7% interest per year. Compounded semi-annually. What is the value of the investment after 10 years? What is the value of the investment after 10 years? We can do these no problem, right? I'll just draw a quick timeline just because it's easier to visualize things that way, right? So here I am today, and then in 10 years, my $500 is going to be some future value. The length of this arrow is n is time times the frequency. The frequency is semi-annually, so f is 2, and I'm told that r is 0.07. Just kind of jotting those down from the question. So n is time, which is 10 times the frequency, which is 2, so I've got 20 compoundings. And even though I'm about to use my calculator, I'm still going to show my work for finding I. I is R over F, which is 0.07 divided by 2. Call it 0.035. So now on our calculator, we can solve this, right? So making a list of all our values that we need to fill in, and interest per year, present value, the payment amount, the future value, the payments per year, and the compoundings per year. And we decided was 20. The interest per year is 7. Right? We use R as the percentage. The present value is 500. And so let's say I'm investing it, right? So it's going to be negative 500 to me. The payment amount is 0, right, until chapter 6. The future value is what we want to solve for, right? So I'm going to put a little star here to say, hey, I'm coming back to this one, but enter 0 for now. The payments per year has to be the same as the compoundings per year, and our compoundings per year is 2. So our payments per year must be 2. Okay. So entering these guys in, right? I've got n is 20, so 20n, 7 interest per year, 500 negative present value, 0 for the payment amounts, and the future value I'm trying to solve for, so I'm going to enter 0 for now, 0 future value. And then going into the payments per year and the compoundings per year, so second payments per year, I'm going to change the payments per year to 2, enter. And then when I scroll down, it'll already have changed my compoundings per year. That's nice. Right, to 2. So then we can second quit this. And now we can go back and hit compute future value. And we get positive $994.89. Right. So we get 994.89. Sure, I'll put a box around it just to say, hey, I calculated this, right? Or I got the calculator to compute this. Okay. So you'll want to do a little bit of practice, right? But once you get the hang of it, right, it's not going to be that bad. You just have to fill in the slots, keeping in mind that the future value and the present value have to have opposite signs, right? But if you had a positive present value there, the answer would be negative, right? But that just means that it's money leaving your hands, right? It doesn't actually mean negative money. Okay. Any questions about that one? No? So do some practice. It'll be pretty fun once you get the hang of it. Okay. So, yeah. Yeah, so for the practice test, all these short answer questions, you don't have to show any work. Okay. So for short answers, as long as the answer is there and it's right, then you don't have to show any work. So then, yeah, you could definitely use your calculator. You wouldn't even have to use, like, show the work on your calculator, right? The only reason you would show work for your short answers, maybe part marks, right? I can't give you part marks for just an answer, right? But I can give you part marks for half an answer as long as you show me what you were thinking, right? So yeah, so for these short answers, a lot of these, right, as long as it's compound interest, because the calculator doesn't do simple interest, right? As long as it's compound interest, you can use your calculator. Oh, rats. Okay. It fell asleep. Oh, what's going on over there, I wonder? I don't know what that is. It's this written over again. Anyways, maybe it'll shake itself out. Nice. Okay, not sure what was going on there. So yeah, so you can definitely use your calculator for all these short answer problems, and even to check your work for the long answers. If you've decided to do it by hand, that's great, right? Doesn't matter. But as you'll see for the long answer, right, so all answers need to have all your work for full marks. If you use your financial calculator to find an answer, be sure to list all the pieces of information you imputed and interest per year, right? So you have to make that list that we were doing to show your work. Yeah. Okay. So, any other questions before we wrap up? So 5.6 is on changing interest rates. So remember, for simple interest, I said, okay, so you've got a rate of 5%, and then every 4 months it's going to go up by 1%. Right, so we've got this changing interest rate scenario. Right, we need to know how to deal with that for compound interest as well. Right. So changing interest rates. If you look on your formula sheet, I think you might suspect that it's this long future value is the present value times 1 plus I1 to the power of N1 times 1 plus I2 to the power of N2 times 1 plus I3 to the power of N3, et cetera, et cetera. That's what we're doing, right? And so you're going to have this changing interest rate for some number of compoundings, right? Each interest rate has some number of compoundings. Then you can use this formula. So we're going to use the future value as the present value times 1 plus I1 to the power of N1 times 1 plus I2 to the power of N2 times up to some kth interest rate change to the power of NK. Right, just the noting, we can have as many as we want, right, in succession. Pardon? Yeah. Where I sub 1, right, is the periodic interest rate for the first amount of time. Right? So the periodic interest rate for first amount of time and N sub 1 is the number of compoundings for the first amount of time. And then I2, same idea, but for the second amount of time. And 2, number of compoundings for the second amount of time. So it's the number of compoundings for the first interest rate. So we'll have a look at example 190. CIBC changes their rate from 4% compounded annually from the start of 2000 to the start of 2002. For the next 2 years, their rate switched to 4.75% compounded quarterly. The following year, the rate was 3.5% compounded semi-annually. You invested $1,000 at the start of 2000. How much do you have in your bank account after 5 years? Right. So this will happen, right? Your interest rate is going to change. So you invest at some interest rate, but then if interest rates go up or if they go down, right, you have to deal with that. Okay. So let's draw this out as a timeline, right? Because we're looking at from the start of 2000 to 5 years later, right, 2005. So here we've got 2000 to 2005. So I've got 2001, 2002, 2003, 2004. 2005. So we'll just map out so we can see what's going on. Right? We don't need to, but it's good. So we invested $1,000. And from the start of 2000 to the start of 2002, right? So for this period of time, the rate was 0.04 compounded annually. Right. For the next 2 years, the rate switched to 4.75%. So just to indicate the rate switch, right, I'm going to drop it down one step here. And for the next 2 years, right, between 2002 and 2004, I've got a rate of 4.75. So the rate is 0.0475 compounded quarterly. So now my F is 4. Right? And then the following year, the rate was 3.5% compounded semi-annually. Right? So between 2004 and 2005, I was only earning 0.035, and the frequency was compounded semi-annually, so 2. You can do one solid line with the changes broken up if you want. Yeah. And then so here we're going to have some future value, right, at 5 years. So we want to figure out our ends, right, the number of compoundings for each of these different time periods, right? Because for the first one, we're compounding annually, right? For the second one, we're compounding quarterly. So even though it's the same length of time, 2 years, right, the number of compoundings is going to be different, right? So up here on the first one, I've got n is time times the frequency. The time is 2 and the frequency is 1. I like to always do the same thing, right? So even though it's obvious that it's 2, right, I'll still say t times f is 1 times 2 is 2, right? Just so I'm always doing the same thing. That way I don't forget as much. Still forget some stuff. Moving on to the second interest rate, right? I've got n is t times f. Time for this little guy is 2, and f is 4. So I've got 8 compoundings here. And then n is time times the frequency, which is 1 year, times the frequency, which is 2, which is 2. So now, right, I want to use little subscripts maybe to denote that I have N1, N2, and N3, right? So I've got N1, N2, and N3. You can squeeze those in. I didn't give myself a lot of room. It was an afterthought. Okay. And now I'm going to calculate the periodic interest rate for each of these rate changes, right? So here I'm going to have I1 is R over F, which is 0.04 divided by 1, which is 0.04. I2 is R over F, which is 0.0475 divided by 4. That one I can't do. 0.0475 divided by 4. So I2 is 0.011875. And then I3 is going to be R over F, which is 0.035 divided by 2. So I3 must be 0.035 divided by 2, 0.0175. You don't have to have the timeline for this, right, necessarily, unless it's part of a long answer question, right, then you do. But if it's just a short answer question, you don't have to have the timeline, just your answer. So we know from our formula sheet that the future value is the present value times 1 plus I1 to the power of n1 times 1 plus I2 to the power of n2 times 1 plus I3 to the power of n3. Right, that's on your formula sheet. Trying to solve the future value. The present value that we invested was $1,000. So 1,000 times 1 plus I1, which is 0.04, to the power of n, which is 2. Times 1 plus 0.011875 to the power of 8 times 1 plus 0.0175 to the power of 2. Oy. Okay. I have a feeling I'll be storing a lot of stuff here. All right. So I've got 1,000 times 1.04 to the power of 2, 1.0816. I'll store that in 1. 1.011875 to the power of 8, 1.09904318. I'll store this in 2. And then 1.0175 to the power of 2, 1.03530625. I'll store that in 3. Why not? So now I've got 1,000 times recall 1 times recall 2 times recall 3. I get $1,230 and 0.69502, just so you can check your decimals. Right. So the future value is 1230.70. Rounding. Nice. So that's how we deal with changing interest rates. The last thing we're going to cover is just quick. It's kind of a mind bender, okay? But we could have investments that are continuously compounded, right? So continuously compounded, which is kind of hard to wrap your head around, right? It's not daily, it's not even hourly, it's not even by the minute, right? It's continuously compounding. Okay. So that's kind of weird to think about, right? But we've got this formula. The last formula in compound interest is how you're going to calculate continuously compounded future values. Okay. Yeah. So 5.7 is on continuously compounded investments. So you're going to use the future values, the present value, same. The only thing that's changing is to account for this continuous compounding, use e to the power of RT. Where R, right, is the nominal rate, same as you've done before, and T is the time in years. So you know R, you know T. Show by example, 192. I know I'm cutting it close, but I still have a little bit of time. A lot of time. So example 192. 13 years ago, you borrowed $7,500 at a rate of 2.5% compounded continuously. What would be the equivalent annually compounded rate at which you borrowed this money? Okay. So, okay. How do we figure this out? So we have 13 years ago. We'll just map it out, see where it gets us to today. So you borrowed 7,500 and the rate was 0.025 and the frequency was continuous. So this is going to grow for T equals 13 years to some future value. So we want to know, okay, what rate, right? What annually compounded interest rate is going to be the same as a continuously compounded interest rate? So first thing we're going to do is we're going to calculate the future value with the continuous compoundings. Right. So the future value is the present value times e to the RT. So the present value is 7,500 times e to the R, which is 0.025, times t, which is 13. So 0.025 times 13, I have 7,500 times e to the power of 0.325. Okay. To solve this on your calculator, pretty sure we go second e to the x. Go second, oh, on your screen, you have 0.325, and then second ln, and then equals. Right, so you have 0.325 second ln, which is the e to the x button, equals, and then I have 1.384030646. So we haven't had a lot of practice doing the e to the power of something on our calculator, but works the same as the others. 7,500 times 1.3840306646. I get 10,380 and 23 pennies to 2 decimal places. Yeah. Yeah. To get that e to the x button. Okay. So now, right, the question says, right, I just want you to finish it on your own. We'll finish it at the beginning of class next day, right? But figure out what rate, what annually compounded rate would get you this future value, right? And that rate would be equivalent to continuous compoundings. If you didn't get a practice test, make sure you grab one because you'll get completion marks on Wednesday. Hand in assignment 2 if you need us, or hand in assignment 1 if you need assignment 2. I've got them. See you Wednesday.
Okay, so this, I just want to clarify. I was having trouble with my calculator.